Hello, welcome to the channel. Maybe you've asked yourself this question before. Could two people repopulate the Earth, just two, in the case of an apocalyptic event that destroys everyone except for two individuals? Could Shinji and Asuka have repopulate the Earth? Stay tuned to find out. Could we repopulate the Earth with just one couple? The first thing that may come to mind is yes, but the offspring would have to engage in incest, and this is indeed true. Obviously, the first new generation would all be siblings, and the second would all be cousins. There is no way to avoid that. Multiple studies have shown that when first or second degree relatives have children together, the results are not favorable. A report that analyzed Czech children born between 1933 and 1970 from closely related parents in Czechoslovakia found higher rates of infant mortality and physical and mental disabilities. Then there's the widespread color blindness on Pinjlap Island, caused after a devastating typhoon in the 18th century left only 20 survivors to repopulate the community. The entire population there now descends from only those 20 individuals. There are also some cases in European royalty where strategic marriages between close relatives were common. One of the most well-known cases is that of Charles II, the King of Spain. His parents were niece and uncle, and he suffered from physical disabilities, mental retardation, and deformities. His tongue was so large that it made speaking very difficult for him, and he died senile and plagued by epileptic attacks. There are many other studies showing the emergence of problems when these types of mixtures occur. But the question you are probably already asking is, why does this happen? Why does inbreeding lead to these issues? The answer is simple. When inbreeding occurs, only a small group of genes is shared, meaning many identical genes are inherited from both parents. This increases the likelihood of genetic diseases. Genetic diversity allows species to overcome problems and adapt to changes in the environment. And that is precisely what is lost when close relatives reproduce. Inbreeding goes against the biological purpose of mating, which is to mix DNA. Human DNA is grouped into 23 pairs of chromosomes, and within each chromosome, there are hundreds of thousands of genes. Additionally, each gene has two copies known as alleles. Genes determine different aspects of your appearance, such as hair and eye color. Just like biological factors such as blood type, these genes are divided into two categories, dominant and recessive. If one of the genes in the pair is dominant, then the result is that you inherit the dominant gene trait. However, for traits that originate from recessive genes, you need both genes to be recessive. For example, the gene for brown eyes is dominant, so having just one of these genes in a pair will result in brown eyes. However, the gene for blue eyes is recessive, so you need both genes to have blue eyes. This is important because certain congenital defects and genetic diseases are carried by recessive alleles. Inbreeding accumulates the chances of being born with such recessive gene conditions against you. As couples who are related have similar, although not identical, DNA, carriers of the same recessive gene increase significantly. That's the reason why the more closely related a family member is, the greater the risk of transmitting diseases. To be more specific, two siblings who have children together have a higher probability of passing on a recessive disease to their children. But how much more likely is it? Well, it turns out that two siblings are 50% related. This means that for any given gene, there is a 1 in 4 chance that they have the same copy of that gene. This, of course, propagates through generations, but it doesn't mean that every individual in every generation will have genetic problems. Remember the case we discussed earlier, the one on Pinjlap Island? How they went from a predominantly colorblind first generation to only a tenth of the population being colorblind today? This could be the answer to how we originated from just one couple hundreds of thousands of years ago without all of us having genetic problems. It would be problematic if we actually descended from a single pair of hominids 300,000 years ago. Don't worry, logic tells us otherwise. Each of us comes from a father and a mother, and it is logical to assume that all of humanity had a father and a mother. However, what we often overlook is that logic alone doesn't work when it comes to complete understanding. So, what does science know about our origins? Science tells us that the first mother never met the first father. But don't despair, we've arrived at the answer. Each of us has 23 pairs of chromosomes, making a total of 46. So far, so good. But what not many people know is that we have a 47th chromosome that resides in our mitochondria. When some say chromosome 47, not everyone does, because mitochondria have their own DNA called mitochondrial DNA, mtDNA, which we only inherit from the mother's egg, not the father's sperm. All the mitochondria in your body have been inherited from your mother. Scientists have traced mitochondria back through several generations to the first woman who had this special mitochondria, approximately 150,000 years ago in Africa. She is popularly known as Mitochondrial Eve. You may have heard of her without fully understanding what it meant. Well, this is the answer. Other Homo sapiens women lived with her, of course. But only the lineage of this Mitochondrial Eve is the one that survives until now. The rest of Homo sapiens are dead. That's our mother, and we are all related to her. Just as we could trace a single lineage of our dear mother humanity because she has special DNA that cannot be combined with any other, we can also trace the lineage of our father with something similar in the chromosomes. These are smaller than the X chromosomes and cannot recombine either. This characteristic has allowed scientists to molecularly trace our father through generations, reaching back approximately between 200,000 and 300,000 years ago. Although it is not well known whether he was in Africa or lived outside of it after the migration, he is much older than our mother. Like our mother, our father coexisted with other Homo sapiens of his time, but only his lineage survives until now. To make it clear, our parents lived in different times and never knew each other. I know what you're thinking. How is this possible? Well, it's a combination of peculiar genetics, unique evolutionary circumstances, and a lot of time. This allowed a fraction of our parents' genes to make their way to us through many generations and mutations. So, going back to the question from the video, could two people repopulate the Earth? It's possible. With a small population size, it's obvious that over time and as the population grows, the effects of inbreeding will become more significant. However, that doesn't mean that life won't find a way. The history of human civilization shows that various small groups of survivors have managed to grow in number and overcome the mathematical odds behind genetics. For example, the uterine community in North America descends from only 18 families. While the evidence of short-term effects due to low genetic diversity is strong, they are still probabilities. As long as the apocalypse doesn't destroy the foundations of modern civilization and as long as this couple has all the means to survive. Like having a robot to safely perform an appendectomy if one of them needs it. Or if the other person is capable of performing such operations, and as long as they complement each other in everything they might need. Allowing them to survive, humanity could recover surprisingly quickly. Going back to the example of inbreeding in the uterine community in North America. This community achieved the highest population growth rates ever recorded, doubling every 17 years. Taking this into account, if this solitary and unique couple had 8 children per woman in each generation, calculations tell us that we would return to a population of 7 billion people. Our current population crisis would be resolved in just 556 years. Isn't that fascinating? Well, it is to me. That's all for this episode of the Sapientious section. I hope you have learned something interesting. Comment below if your grandmother's name is Eve. Thank you for watching this video. If you liked it, give it a thumbs up and subscribe.